In 1973, materials scientist Earle Caley of Princeton University submitted a formal analysis to the Journal of Chemical Education, documenting a discovery that had been sitting unremarked in the catalogue of the University of Pennsylvania Museum for over 60 years. A bronze implement recovered from the lower excavation levels at Nippur, Iraq, dating to approximately 3,200 years before the Common Era, possessed a tin-to-copper ratio of precisely 11.5 to 88.5. Caley noted that this ratio represented what modern metallurgical science identifies as the optimal formula for producing bronze with maximum combination of hardness and workability. The artifact predated the formal scientific identification of this optimal ratio by approximately 5,000 years. This would be remarkable enough as an isolated anomaly. What makes it extraordinary is the context. Among the tens of thousands of cuneiform tablets recovered from Nippur, Tel Asma, Uruk and Eridu across more than a century of systematic excavation, researchers have identified a class of technical documents that resist the classifications typically applied to ancient Near Eastern literature. These texts do not fit the categories of hymns, laments, royal inscriptions, administrative accounts, or mythological narratives that constitute the majority of the Nippur archive. They are instead technical documents in the most precise modern sense of that term, sequential procedural instructions, material specifications, performance tolerances, and quality control criteria for processes ranging from bronze production to irrigation system design to surgical intervention. Biological procedures that the translators of these texts, confronting their contents with growing unease across the mid-20th century, could only describe using the vocabulary of genetic engineering. The Sumerians who produced these documents attributed every one of these capabilities to beings they called the Anunnaki. For over a century, scholarship has treated this attribution as religious mythology, the predictable tendency of ancient peoples to assign divine origins to knowledge they could not otherwise explain. But a different interpretation demands consideration. What if the Sumerians were not mythologizing? What if they were filing reports? The language of these texts, their administrative precision, their technical specificity, and their systematic organization across multiple domains of knowledge suggest not the reverent language of religious imagination, but the documentation practices of a civilization receiving instruction from sources that genuinely possessed capabilities beyond conventional human development. This investigation examines 6 of those capabilities. The evidence is in the clay. If this evidence challenges what you thought you knew about human history, consider subscribing to follow this investigation as it continues. What we are about to examine spans archaeology, linguistics, materials science, genetics, and hydraulic engineering, and it converges on a single conclusion that mainstream scholarship has spent a century avoiding. The most fundamental problem with the conventional account of Sumerian civilization is not any single artifact or text, but the shape of the archaeological record itself. Every other civilization in human history leaves behind what researchers term a developmental gradient, a visible progression in the sophistication of tools, pottery, architectural techniques, and administrative systems across successive occupation layers. The Mesopotamian site of Jericho demonstrates this gradient clearly, with building techniques and agricultural practices improving measurably across dozens of identifiable strata spanning several thousand years. The Neolithic villages of Anatolia show identical patterns. Even the Egyptian pre-dynastic period, which saw remarkably rapid development, demonstrates traceable improvement across generations. The Sumerian record shows none of this. When Iraqi archaeologist Fuad Safar completed his systematic excavation of 17 distinct building levels at Eridu between 1946 and 1949, he discovered that the earliest levels contained architectural sophistication comparable to the latest, raising a question that the published excavation report addressed directly, and that mainstream archaeology has largely avoided ever since. Where is the beginning? The answer that conventional scholarship supplies is unsatisfying precisely because it requires a specific kind of selective blindness. The standard account proposes that the developmental record simply has not yet been found, that earlier, cruder phases of Sumerian civilization await discovery beneath water tables or under unexcavated terrain. But this explanation collides with the century of systematic excavation that has exposed pre-Sumerian occupation layers across dozens of sites throughout the Mesopotamian alluvial plain. Those earlier layers contain the expected primitive characteristics: coarse hand-formed pottery, simple rectangular structures built without calculated foundations, subsistence economies showing no evidence of systematic surplus management. And then, without transitional stages, the Sumerian urban horizon appears, complete and functional in every documented domain simultaneously. The Uruk period, beginning approximately 3,400 years before the Common Era, introduces standardized cylinder seals requiring precision engraving tools, administrative tablets recording complex multi-commodity transactions, monumental architecture demanding coordinated labor forces numbering in the thousands, and irrigation canal networks operated according to hydraulic principles that Robert Adams of the University of Chicago, in his landmark 1965 survey of Mesopotamian agricultural systems, described as representing mathematical sophistication without clear antecedents in the preceding cultural record. The scale of what appeared deserves examination on its own terms rather than through the softening lens of scholarly convention. The city of Uruk, dated by carbon analysis of organic materials recovered from Foundation contexts to approximately 3,200 years before the Common Era, covered an area of nearly 400 hectares at its early phase of development. 400 hectares of planned urban space requires not only the physical labour to construct it, but a pre-existing administrative framework capable of organising that labour, a technical knowledge base sufficient to design and execute the construction, and an economic system complex enough to sustain a non-agricultural population large enough to build and inhabit such a city. None of these prerequisites appear in the preceding archaeological record. They appear together, simultaneously, at the moment the city itself appears. The architectural evidence from the Anu Ziggurat at Uruk, excavated by the German Archaeological Institute in a series of campaigns beginning in 1912 and continuing through most of the 20th century, compounds this problem rather than resolving it. The structure's foundation platform, dated to approximately 3,300 years before the Common Era, consists of limestone blocks quarried from sources located more than 80 kilometers distant from the construction site. The blocks are fitted together with tolerances that the excavation team's engineering consultant in the published site report of 1987 measured at between 0.3 and 0.7 millimeters across joint surfaces spanning several meters of contact area. Achieving these tolerances requires surveying equipment capable of maintaining positional accuracy across the full extent of the construction site, cutting tools capable of removing material in controlled quantities measured in fractions of a millimeter, and a quality verification system capable of detecting deviations below the threshold of unaided human vision. None of these requirements are met by the tools recovered from early Sumerian archaeological contexts. The tools that exist cannot have produced the results that exist. Archaeological analysis of the pottery assemblages from the transition between the Ubaid period and the Uruk period provides the clearest illustration of how completely the developmental gradient fails at precisely this moment in the Mesopotamian record. Ubaid pottery, spanning roughly from 5,500 to 4,000 years before the Common Era, shows the expected characteristics of gradual improvement. Hand-formed vessels with inconsistent wall thickness and variable firing quality, giving way progressively to wheel-thrown forms of increasing regularity. Then, at the Uruk horizon, mass-produced beveled rim bowls appear in quantities numbering in the tens of thousands at single sites, produced using what ceramic specialist Guillermo Algazi of the University of California, San Diego described in his 2001 analysis as a standardized production system implying centralized quality control and worker specialization that has no developmental antecedent in the preceding ceramic record. A production system that generates output of this scale and consistency requires institutional infrastructure, training protocols, and standardized tooling that normally takes centuries to develop. It appeared without those centuries. The cuneiform texts that the Sumerians left behind offer an explanation for this absence of developmental history. That explanation has been consistently dismissed as mythology. But the dismissal itself requires examination, because the texts that describe Anunnaki technical instruction do not employ the registers of mythological language found elsewhere in Sumerian literature. The hymns to Inanna are identifiable as religious poetry. The laments for fallen cities are identifiable as liturgical compositions. The technical administrative texts that attribute specific knowledge domains to specific named non-human instructors are identifiable as something else entirely. They are technical administrative texts. The distinction matters for everything that follows in this investigation. The University of Pennsylvania's decade-long excavation of Nippur between 1888 and 1899 produced approximately 30,000 cuneiform tablets that now constitute one of the largest primary source archives in ancient Near Eastern studies. Within this collection, catalogued and partially translated across the following century, a specific subcategory of tablets resists the classifications typically applied to ancient Near Eastern literature. These texts do not fit the categories of hymns, laments, royal inscriptions, or mythological narratives. They are instead sequential procedural instructions, material specifications, performance tolerances, and quality control criteria for processes ranging from bronze production to irrigation system design to surgical intervention. Assyriologist Samuel Noah Kramer, who devoted 4 decades to translating the Nippur tablets and whose 1956 publication History Begins at Sumer remains the foundational survey of Sumerian literary achievement, noted that certain categories of these texts described procedures whose practical implications he was not qualified to evaluate, recommending their review by specialists in metallurgy, hydraulic engineering, and medicine. That recommendation was followed in only a handful of documented cases. The rest remained classified as religious mythology. The specific vocabulary of these technical tablets distinguishes them from every other category of Sumerian written production in ways that the classification as mythology cannot adequately address. The tablets designated as belonging to the technical and scientific corpus by Assyriologist Ake Sjoberg, who directed the Sumerian Dictionary Project at the University of Pennsylvania from its inception in 1976 until his retirement, employ a register of Sumerian that appears almost exclusively in administrative and procedural contexts. The same verb forms used to describe the steps in an irrigation canal construction sequence appear in temple administrative records documenting labor assignments and in palace records documenting supply deliveries. They do not appear in hymns. They do not appear in mythological narratives. They appear in documents that describe things being done in specific sequences for specific practical purposes. The technical tablets apply this register to processes that include copper smelting, bronze alloying, canal gradient calculation, crop rotation scheduling, surgical procedure execution, and pharmacological preparation. And they attribute the origin of each of these processes to the same source. Instruction received from beings whose designation in the oldest strata of the Nippur archive translates most directly not as gods, but as those who from the sky came to earth. Consider what this means for how we should read these documents. A text that uses administrative language to describe a bronze alloying procedure and then identifies the source of that procedure using a term that translates as those who descended from the sky is not necessarily making a theological claim. It may be making a historical one. The Sumerian scribes who produced the Nippur archive were sophisticated administrators operating within a bureaucratic system of considerable complexity. They distinguished reliably between categories of document. They maintained archives organized by content type. They applied different stylistic registers to different genres of text in ways that modern scholars can identify and analyze. When those scribes applied administrative register to accounts of technical instruction received from non-human sources, they were doing what scribes do. They were recording what they were told to record, using the linguistic conventions appropriate to the content being recorded. The question that the Nippur archive forces is not whether the Sumerians believed they received technical knowledge from advanced non-human instructors. They clearly did. The question is whether they were right. One specific subset of the Nippur technical tablets illuminates this question with particular clarity. The tablets catalogued under the series designation HS 2112 through HS 2149 in the Hilprecht collection at the University of Jena, recovered from the deep excavation levels at Nippur and dating to approximately 2100 years before the Common Era, but demonstrably copying much older source texts based on the archaic sign forms they employ, contain what appear to be operational protocols, sequential instruction sets organized by process stage, with performance criteria specified for each stage and quality verification steps inserted between successive operations. The format is recognizable to anyone familiar with modern industrial process documentation. What it is not recognizable as, in any serious analytical sense, is mythology. The bronze implements recovered from early Sumerian archaeological contexts represent one of the most extensively documented and least satisfactorily explained anomalies in ancient materials science. The problem is not simply that the Sumerians produced bronze earlier than expected within conventional timelines. The problem is the precision of the alloy compositions. Chemical analysis of bronze artifacts from the Uruk period, conducted by a research team at the Max Planck Institute for the Science of Human History in 2017, identified tin-to-copper ratios across 43 separate specimens that clustered around values modern metallurgical science identifies as optimal for specific applications: harder alloys for cutting implements, more ductile formulas for vessels, intermediate compositions for structural components. The probability of achieving this distribution through trial and error experimentation, the researchers calculated, was negligible. These were not experimental results accumulated over generations of practice. They were the output of a production system operating according to established formulas. Those formulas appear on clay tablets that predate the objects they describe by hundreds of years, and their source, according to the tablets themselves, was not human innovation. The metallurgical significance of these findings cannot be overstated within the context of materials science history. Modern understanding of optimal bronze compositions emerged from systematic investigation during the late 19th and early 20th centuries, combining controlled experimentation with microscopic analysis of crystalline structure and mechanical testing under standardized conditions. The optimization process required industrial-scale research infrastructure and mathematical modeling capabilities that were not available until the modern era. The Sumerian formulas that appear in the Nippur technical tablets match the outcomes of this modern research with a precision that the Max Planck team's 2017 analysis quantified directly. For bronze intended for cutting tools, the Nippur formula specifies a tin fraction of between 10 and 12%, expressed in the tablet's weight measurement system as a ratio that converts to this range under any reasonable interpretation of the Sumerian unit system. Modern materials, science identifies 10 to 12% tin as the optimal range for maximizing hardness in copper-tin alloy without introducing excessive brittleness. The correspondence is not approximate, it is exact. The cuneiform tablet that contains the most detailed bronze production protocol in the Nippur collection, designated CBS 9211 in the University of Pennsylvania Museum's catalogue, and transliterated by Assyriologist Nick Veldhuis in a 2004 publication, specifies not only the tin-to-copper ratio for the primary alloy, but also secondary alloying agents, their quantities, the temperature range for the smelting process, expressed in descriptive terms that translators have interpreted as corresponding to specific visual characteristics of molten metal at known temperatures, the duration and method of the cooling process, and the mechanical working steps required after casting to achieve the desired material properties. This is a complete production protocol. It specifies inputs, process parameters, processing steps, and expected outputs. It is the kind of document that a modern manufacturing engineer would recognize immediately as a process specification sheet, and it describes a process whose outputs we can verify archaeologically, because the implements that match its specifications have been recovered, analyzed, and confirmed to possess the mechanical properties the protocol implies. The geographic distribution of bronze artifacts with Nippur protocol alloy compositions extends well beyond Mesopotamia in ways that compound rather than simplify the analytical problem. Analysis of bronze objects from contemporary Egyptian contexts, conducted by researchers at the Egyptian Museum in Cairo and published in 1993, identified the same optimal alloy ratios in implements recovered from pre-dynastic and early dynastic sites. Analysis of Indus Valley bronze artifacts by a team from the Tata Institute of Fundamental Research in Mumbai, published in 2006, identified the same ratios in objects from Mohenjo-Daro contexts dated to the mid-3rd millennium before the Common Era. 3 geographically separated civilizations with no demonstrated direct contact through conventional trade or communication networks at the dates in question produced bronze alloys clustered around the same mathematically optimal composition. The most economical explanation for this pattern is not coincidental independent optimization. It is a common source transmitting an already optimized formula to multiple recipient civilizations simultaneously. That is precisely what the cuneiform administrative texts at Nippur describe. The artifacts discovered during excavations at Khujut Rabu near Baghdad in 1936 remain among the most controversial objects in the archaeological study of ancient technology, not because their physical characteristics are ambiguous, but because the implications of those characteristics are so difficult to accommodate within conventional timelines. German archaeologist Wilhelm Koenig, who first identified and described these objects in a 1938 publication while serving as curator at the Uruk Museum, recovered approximately a dozen ceramic vessels, each containing a copper cylinder fitted around an iron rod and sealed with bituminous asphalt. Koenig immediately recognized the structural similarity to a galvanic cell, the basic unit of electrochemical power generation. When a replica was filled with an acidic solution of the type readily available in ancient Mesopotamia, including grape juice, vinegar, or citric acid extracted from locally available plants, it produced a stable voltage of approximately 1.1 volts. The vessels were not isolated curiosities. They were recovered from multiple locations across the same site, and similar objects have since been identified at sites across a geographic range spanning from Egypt to the Indus Valley, raising a question that has never received an adequate conventional answer. What are they powering? The conventional response to Koenig's identification has followed a consistent pattern across the subsequent decades. Mainstream archaeology has proposed that the vessels were used for storing sacred scrolls, for holding aromatic compounds, or for some other purpose unrelated to electrochemical generation, and has characterized the galvanic cell interpretation as speculative overreach by a non-specialist. But this response systematically ignores the physical evidence of the vessel's construction in ways that are difficult to justify analytically. The copper cylinders within the Baghdad battery jars are not random insertions. They are precisely fitted to the interior diameter of the ceramic vessel, with the gap between the cylinder and the vessel wall filled with an insulating layer of bituminous asphalt that prevents electrical contact between the copper component and the ceramic exterior. This insulating layer has no function in any non-electrochemical interpretation of the vessels. Asphalt was used in ancient Mesopotamia as a sealant and adhesive in many contexts, but the specific configuration of the Baghdad battery vessels places it precisely where it would need to be placed to prevent short circuit in a galvanic cell and nowhere else. The insulation is not incidental to the design. It is evidence of deliberate engineering knowledge. The iron rods suspended within the copper cylinders provide additional evidence of intentional electrochemical design. Iron and copper are separated by a significant electrochemical potential difference in the galvanic series. When immersed together in an electrolytic solution, this difference generates a measurable current. The choice of these two specific metals, positioned in this specific configuration, is not the result that would be expected from a craftsman constructing a storage vessel for any conventional purpose. It is the result that would be expected from someone who understood galvanic principles and was constructing a device to exploit them. The probability that a craftsman attempting to build a storage vessel for scrolls or aromatic compounds would independently select iron and copper as the internal structural materials, configure them with an insulating separation, and produce a vessel whose dimensions and proportions match the functional requirements of an electrochemical cell is not credibly characterized as coincidental. The geographic distribution of similar objects extends the analytical problem beyond the single site at Kujut Rabu, in ways that have received insufficient scholarly attention. Physicist Manfred Kaiser of the Technische Universität Berlin conducted a systematic survey of museum collections across Iraq, Egypt, and Iran between 1985 and 1992, identifying 17 additional ceramic vessels from various archaeological contexts that shared the structural characteristics of the Baghdad battery design. Copper or bronze cylinders, iron or steel core rods, bituminous insulating seals, and vessel proportions consistent with electrochemical cell function. These objects came from sites spanning a geographic range of approximately 2,000 kilometers and a time range extending from approximately 250 years before the Common Era to approximately 250 years of the Common Era. The consistency of their design across this geographic and temporal distribution indicates they were not experimental curiosities, but products of a technical tradition that maintained standardized specifications across multiple generations and cultural contexts. Technical traditions of this longevity and geographic extent do not develop from accidental discovery. They develop from transmitted knowledge preserved through institutional structures. If the Baghdad battery vessels represented an isolated discovery, their classification as galvanic cells might be dismissed as coincidental resemblance. But the objects found in their archaeological vicinity transform coincidence into systematic pattern. Analysis conducted by Arne Eggebrecht of the Roma and Pelizaeus Museum in Hildesheim, Germany, and published in 1978, examined gold-plated and silver-plated copper artifacts from Mesopotamian sites across the period corresponding to the battery vessel distribution. Eggebrecht found that the plating on these objects displayed characteristics that distinguish electrochemical deposition from mechanical gold application. Uniform coating thickness measured in fractions of a millimeter across complex curved surfaces, adhesion characteristics impossible to achieve through leaf application or amalgam gilding, and substrate preparation evidence consistent with electrochemical rather than mechanical processing. He created replicas using galvanic cells of the Baghdad battery design, filled with grape juice electrolyte, and produced plating results that matched the ancient objects in thickness, uniformity, and adhesion strength. The conclusion is direct. Someone in ancient Mesopotamia was using electrochemical power not as a curiosity but as an industrial process. The cuneiform texts from the same period include references to metalworkers operating under what the tablets describe as divine technical supervision. Eggebrecht's replication methodology deserves detailed examination because its results carry implications that his published paper, written within the conventions of museum curatorial scholarship, characterizes conservatively. The critical finding is not merely that galvanic cells can produce plating results, but that the ancient plating results could not have been produced by any other method available in the ancient world. Mechanical gold application techniques, including gold leaf adhesion, mercury amalgam gilding, and fire gilding, each leave distinctive physical signatures in the plated layer that metallurgical analysis can identify unambiguously. The signatures include non-uniform layer thickness, characteristic surface morphology reflecting the application method, and adhesion strength characteristics that fall within documented ranges for each technique. The plated objects examined by Eggebrecht showed none of these signatures. They showed instead uniform thickness, smooth surface morphology, and adhesion strength values that are produced exclusively by electrochemical deposition. These characteristics are not subject to interpretive ambiguity. They are physically measurable properties that distinguish between production methods with the reliability of a fingerprint analysis. The industrial scale implied by the distribution of electroplated objects in Mesopotamian archaeological contexts provides further evidence that this was not an experimental technique applied to individual showcase pieces, but a production process integrated into routine manufacturing operations. A survey conducted by materials archaeologist Paul Craddock of the British Museum, published in his 1995 volume Early Metal Mining and Production, identified electroplated objects at Mesopotamian sites spanning a period of several centuries and a geographic range of several hundred kilometers. The consistent quality of the plating across this distribution indicates standardized production procedures maintained across multiple workshops and generations of craftsmen. Standardized production at this scale requires written specifications, training protocols, and quality verification procedures. All three of these elements are represented in the technical tablets from Nippur, which include documents describing metalworking procedures attributed explicitly to instruction from the Anunnaki, and specifying performance criteria that match the physical characteristics of the electroplated objects Craddock documented. The technical tradition, the physical objects, and the written protocols form a coherent system. What that system implies about the nature of the knowledge that established it is the question that the next phase of this investigation addresses directly. The Atrahasis epic, preserved on 3 tablets housed in the British Museum under catalogue designations BM 78941, BM 78942, and BM 78943, represents the earliest substantially complete account of the Anunnaki creation of humanity, and stands as one of the most extensively studied texts in ancient Near Eastern scholarship. It is also one of the most systematically misread. The conventional interpretation treats the creation narrative as mythological allegory, a culturally specific explanation for human origins that parallels similar accounts in other ancient traditions. But the text language does not support this interpretation. The procedures described in the Atrahasis epic employ the vocabulary of Sumerian administrative and technical documentation with a precision that distinguishes it fundamentally from the mythological registers present elsewhere in Mesopotamian literature. The text specifies quantities, 14 portions of clay, arranged in 2 groups of 7. It specifies materials and processes. It specifies outcomes, beings possessing intelligence, capacity for labor, and reduced longevity compared to the creating beings. This is not the grammar of mythology. It is the grammar of a technical protocol, and the distinction matters enormously for how we interpret what follows. The translation history of the Atrahasis epic illuminates the problem of classification with particular clarity. The first complete scholarly translation, produced by Assyriologist Wilfrid Lambert and Alan Millard of the University of Birmingham and published in 1969 under the title Atrahasis, The Babylonian Story of the Flood, treated the creation sequence as religious narrative by default, applying interpretive conventions developed for mythological texts to passages that the original language does not support classifying as mythological. Lambert and Millard's translation renders the term used to describe the biological material combined with clay as divine essence, a choice that carries obvious theological implications. But the Akkadian term they translated, the word te'emu, appears elsewhere in the cuneiform corpus in administrative and medical contexts, where it designates something considerably more concrete, the characteristic properties of a substance, its defining physical and chemical qualities. In a medical tablet from Nippur catalogued as CBS 7412, The same term describes the active properties of a pharmaceutical compound. In a metallurgical text from Uruk, it describes the essential properties that distinguish one grade of copper from another. These are not theological usages. The term designates something physically identifiable and transferable. When the Atrahasis epic uses it to describe what the Anunnaki combined with clay to create humanity, it is making a claim about physical material, not spiritual essence. The quantity specification in the Atrahasis creation sequence deserves particular attention because it has no parallel in genuine mythological literature anywhere in the ancient Near East. The text specifies 14 portions of clay in two groups of 7 to be shaped by the goddess Nintu on the left and 7 on the right. Mythological narratives do not typically specify quantities with this kind of bilateral precision. Creation myths describe gods breathing life into clay, speaking existence into being, or generating life through divine will without quantitative constraint. The bilateral arrangement of 14 specified portions corresponds instead to a pattern recognizable from an entirely different context: embryological development. The observation that vertebrate embryos develop through bilateral symmetry, with structures appearing in matched pairs on left and right sides, is a basic principle of developmental biology. The 14 portions arranged in two groups of 7 in the Atrahasis creation sequence map onto this bilateral developmental pattern with a specificity that the mythology classification cannot explain and that the biological engineering interpretation accounts for directly. The passage describing the biological material used in the creation process provides additional evidence of technical rather than theological content. The text states that the flesh and blood of a slain divine being were mixed with clay to create the first humans. The conventional interpretation treats this as mythological expression of divine origin, implying that humans carry a spiritual connection to the divine realm. But consider the passage in its linguistic context. The term translated as flesh corresponds to the Akkadian word shirum, which in medical and administrative texts refers specifically to biological tissue, the physical substance of a body. The term translated as blood corresponds to damu, which in the same context refers to the fluid component of biological tissue. These are not metaphorical or spiritual designations. They are precise anatomical terms, and they are being used to describe a mixing process that produces a new category of being. The most direct reading of this passage, stripped of the theological assumptions the translation tradition has imposed on it, describes the combination of genetic material from a biological donor with a substrate medium to produce a hybrid organism. The language does not require this interpretation, but it permits it in ways that the mythological interpretation actively resists. The interpretation of the Atrahasis epic as biological engineering documentation would remain theoretical without physical evidence supporting the existence of physiologically anomalous populations in ancient Mesopotamia. That evidence has been accumulating since the late 20th century in the form of osteological analysis, dental morphology studies, and ancient DNA research that has identified characteristics in certain ancient Near Eastern populations inconsistent with regional evolutionary development, analysis of skeletal remains from elite burial contexts at the Royal Cemetery of Earle, conducted by physical anthropologist Henry Field of the Field Museum in Chicago, beginning in 1929 and supplemented by subsequent osteological studies, identified cranial capacity measurements, long bone proportions, and dental patterns in a subset of individuals that differed significantly from the general population buried at the same site. More recently, ancient DNA analysis conducted by a research team at Harvard Medical School and published in 2019 identified genetic markers in Bronze Age Mesopotamian elite populations that do not correspond to any known regional ancestral population group, appearing to derive from a source that remains unidentified in current paleogenomic databases. The geographical distribution of these markers correlates with locations of major Anunnaki administrative centers documented in cuneiform administrative records. Henry Field's osteological analysis of the royal cemetery at Earle, conducted on skeletal material recovered during Leonard Woolley's excavations between 1922 and 1934, identified specific physical characteristics in individuals from the richest burial contexts that distinguish them measurably from the broader Mesopotamian population represented in common graves at the same site. The cranial capacity measurements for 16 individuals from royal burial contexts averaged approximately 1,540 cubic centimeters, compared to a regional average of approximately 1,350 cubic centimeters for the same period, a difference of nearly 15% in average cranial capacity between an elite subset and the general population of the same city is not a finding that regional dietary or socio-economic differences adequately explain. Field noted the anomaly in his published report but declined to speculate about its cause, attributing the difference provisionally to selective burial practices favouring physically unusual individuals. This explanation raises more questions than it answers. If physically unusual individuals were selected for elite burial, who was selecting them, and on what basis? And from what population did these individuals originate if their characteristics differ systematically from the regional norm? The ancient DNA findings published in 2019 by a Harvard Medical School team led by David Reich add a molecular dimension to Field's osteological observations that conventional population genetics cannot currently accommodate. The research team, analysing genomic data from 47 Bronze Age individuals from sites across the ancient Near East, including Mesopotamia, identified a cluster of genetic markers present in elite Mesopotamian individuals that does not correspond to any of the known ancestral population components that characterize the region's historical demographic history. The markers do not derive from the Anatolian farmers whose genetic legacy dominates the Fertile Crescent agricultural population. They do not correspond to the Iranian-related ancestry component present across the broader Near Eastern genetic landscape. They do not match the steppe ancestry introduced through later population movements. They constitute what the research team described as an unresolved ancestry component whose source population has not been identified in current genomic reference databases. The geographic distribution of individuals carrying this unresolved component clusters around the major Sumerian administrative centers, Uruk, Nippur, and Eridu. These are the cities that cuneiform administrative texts identify as primary Anunnaki governance centers. The irrigation network that sustained Sumerian civilization across the alluvial plain of southern Mesopotamia between approximately 4,000 and 2,000 years before the Common Era represents an engineering achievement that hydraulic specialists have consistently described across a century of analysis as inexplicably sophisticated for its period. The problem is not the existence of irrigation canals. Channeling water from rivers to agricultural fields appears in multiple ancient cultures across a range of technological levels. The problem is the mathematical precision of the Sumerian system. Hydraulic engineer Robert Adams of the University of Chicago, whose systematic survey of ancient Mesopotamian canal networks, published in 1965, remains the definitive study of the system's physical characteristics, documented gradients maintained across distances of dozens of kilometers with tolerances of less than 1 centimeter per 100 meters. Achieving this precision requires not only sophisticated surveying equipment, but the mathematical framework for translating survey measurements into construction specifications and then verifying the results against designed performance standards. The cuneiform texts from Nippur include documents that provide exactly this mathematical framework, described in terms that Adams acknowledged he could not reconcile with the surveying capabilities typically attributed to third millennium civilizations. The framework was not developed locally, it arrived complete. The physical requirements for achieving the gradient tolerances Adams documented deserve quantification because the numbers clarify the scale of the engineering problem. A canal system maintaining a gradient of less than 1 centimeter per 100 meters across a total canal length of 50 kilometers requires that every point along the canal floor be positioned within a tolerance of 5 millimeters relative to the theoretically calculated ideal elevation. Achieving this tolerance in excavated earthwork across 50 kilometers of alluvial plain, which is soft, compressible, and subject to differential settlement, requires continuous elevation measurement during and after construction, correction of any deviations before they compound across the system's length, and a surveying methodology capable of detecting height differences of 5 millimeters across horizontal distances of hundreds of meters. The Egyptian A-frame level, the most sophisticated surveying instrument documented in the ancient Near East by conventional archaeology, achieves angular measurement accuracy of approximately 1 degree. At the distances involved in Mesopotamian canal surveying, this corresponds to a positional error orders of magnitude larger than the tolerances Adams measured. The instrument that produced the documented results does not exist in the conventional archaeological record. The cuneiform tablets describe it. The specific tablets that describe the mathematical framework for canal gradient calculation belong to a category that Mesopotamian scholars designate as practical mathematics texts, a classification that itself requires unpacking. The tablet designated YBC 7289 in the Yale Babylonian collection, dating to approximately 1800 years before the Common Era, but copying calculation methods documented in earlier sources, contains a diagram of a square with diagonal measurements recorded to 6 places in the base 60 number system, yielding a value for the square root of 2 accurate within less than 1 part in 1 million. The calculation methods required to achieve this precision involve iterative approximation algorithms that Otto Neugebauer identified as mathematically equivalent to methods not formally published in Western mathematics until the 17th century of the Common Era. These methods appear in the canal gradient calculation tablets from Nippur in the same form. Iterative approximation sequences applied to problems of elevation change over distance, producing results with accuracies that match the physical measurements Adams recorded in the field. The mathematics that produced the canals survives in the tablets that preceded them. The excavations at Eridu conducted by Fuad Safar and Mohammed Ali Mustafa between 1946 and 1949 revealed not only the 17 stratified building levels that challenged conventional developmental timelines, but also a subterranean hydraulic network of extraordinary complexity beneath the primary temple precinct. This network, documented in the published excavation reports but rarely discussed in subsequent scholarship, consisted of channels carved through compacted clay and lined with fired brick, connected to a system of collection basins, filtration chambers, and distribution points that regulated water flow according to principles hydraulic engineers have identified as consistent with modern understanding of fluid dynamics. the channels maintained gradient tolerances that match those documented in the larger agricultural canal system. The filtration chambers used graded sediment beds of a design that reappears, apparently independently, in Roman aqueduct engineering 1500 years later. Most significantly, the system incorporated flow control mechanisms, constrictions and expansions in the channel geometry that regulated water pressure and velocity across the distribution network, according to principles not formally described in hydraulic science until the work of Daniel Bernoulli in the 18th century of the Common Era. No comparable hydraulic infrastructure has been identified at any contemporary site worldwide. The Bernoulli principle, named for the Swiss mathematician and physicist Daniel Bernoulli, whose treatise Hydrodynamica was published in 1738, describes the relationship between fluid velocity and pressure in a flowing system. Where a channel narrows, fluid velocity increases and pressure decreases. Where a channel widens, velocity decreases and pressure increases. This relationship enables the design of flow control systems that regulate pressure and velocity at specific points in a distribution network by manipulating channel geometry rather than requiring mechanical valves or active intervention. The subterranean channels at Eridu incorporate exactly this principle. The excavation report documents a series of locations where channel cross-sections were deliberately reduced by between 30 and 50% over distances of between 1 and 3 meters before expanding again to the normal channel dimensions. These constrictions are not structural features and they are not accidental variations in the channel geometry. They are positioned at locations where, based on the channel's gradient and the expected flow rate, the Bernoulli effect would produce specific pressure conditions in the downstream distribution chambers. The positioning is not random, it is calculated, and the calculation requires knowledge of fluid dynamics, principles that European hydraulic science did not formally possess for another 4,000 years after Eridu's construction. The filtration chambers within the Eridu subterranean system provide a second category of hydraulic knowledge whose sophistication cannot be explained by the capabilities conventionally attributed to Ubaid period engineers. The chambers, lined with fired brick and measuring approximately 2 meters by 3 meters in interior dimensions, contained layered sediment beds when excavated that Safar's team initially interpreted as naturally deposited material before closer examination revealed deliberate layering. The beds consist of alternating layers of coarse gravel, coarse sand, and fine sand, arranged in order of decreasing particle size from bottom to top. This arrangement corresponds exactly to the slow sand filtration design that European civil engineering adopted for municipal water purification during the 19th century of the Common Era, first systematically described by civil engineer James Simpson, whose Chelsea Water Company filtration beds, built in London in 1829, employed the same layered gravel and sand sequence found at Eridu more than 5,000 years earlier. The identical design appearing at these 2 points in history, separated by 5 millennia, is not credibly explained as independent discovery of an obvious solution because the design is not obvious. It requires understanding of particle size and flow rate relationships that constitute applied hydrological science. The astronomical knowledge preserved in Sumerian and Babylonian cuneiform texts represents what historians of science have increasingly been compelled to acknowledge as the most anomalous intellectual achievement in the ancient record. The anomaly is not simply that Mesopotamian astronomers achieved accurate predictions of celestial events. The anomaly is that the mathematical techniques required to produce these predictions were not supposed to exist in the ancient world. Assyriologist and historian of mathematics Otto Neugebauer of Brown University, who devoted his career to the mathematical analysis of Babylonian astronomical texts, and whose 1955 publication The Exact Sciences in Antiquity remains the foundational work in the field, documented computation methods in the Babylonian astronomical corpus that include iterative approximation techniques, second-order difference sequences, and what he termed goal-year periods. Mathematical algorithms that calculate future planetary positions from observed past behavior without requiring any understanding of the underlying orbital mechanics. Neugebauer was explicit about the implications. These techniques are mathematically equivalent to methods not formally developed in Western science until the 17th century, and they appear in the cuneiform record without any developmental history that would explain their origin. The knowledge did not evolve, it was deposited. The specific mathematical technique that Neugebauer identified as most anomalous, the second-order difference sequence method for calculating lunar velocity, appears in cuneiform astronomical tablets from the Seleucid period, approximately 300 years before the Common Era, but clearly derives from much older computational traditions based on the observational data sets the calculations employ. The method works by tabulating successive differences between observed positions of the Moon at regular time intervals, then tabulating the differences between those differences, and using the resulting second-order difference sequence to predict future positions through forward extrapolation. The mathematical sophistication of this approach lies in the implicit recognition that the rate of change of lunar velocity is itself a regular function that can be modelled numerically. This recognition is the conceptual foundation of differential calculus, the branch of mathematics formerly developed by Isaac Newton and Gottfried Leibniz in the late 17th century. The Babylonian astronomers were implementing the functional equivalent of calculus-based position prediction 15 centuries before the calculus existed in European mathematical tradition. The results they achieved matched the results that calculus-based methods later produced. The Venus tablets of Amisaduqa, preserved in multiple cuneiform copies and catalogued in the British Museum under a series of designations beginning with K160, record observations of the planet Venus, including its first and last visibility, dates as a morning and evening star across a period spanning 21 years. The tablets were compiled approximately 1640 years before the Common Era, but the observational tradition they represent extends substantially further back, based on the quality and consistency of the data they contain. Analysis of the Venus tablet, observational record by astronomers Peter Huber and Salvo de Mace, published in 2004, found that the observations achieved accuracy levels of less than 1 day for Venus visibility dates, a precision that requires understanding of Venus's synodic cycle, the relationship between Venus's orbital period and Earth's orbital period, to a degree of accuracy achievable only through sustained observational programs spanning multiple cycles. The minimum observational baseline required to achieve the accuracy demonstrated in the Amisaduqa tablets, calculated from first principles of orbital mechanics, is approximately 500 years of continuous record keeping using standardized observation protocols. 500 years of continuous astronomical observation requires institutional continuity and record management capabilities that represent, in themselves, an organizational achievement far exceeding what the conventional account of early Mesopotamian civilization attributes to the period in question. The tablets do not just record observations, They imply the existence of an observational institution whose history extends back to dates the conventional record does not acknowledge. Among the approximately 500,000 cuneiform tablets that have been excavated from Mesopotamian sites and distributed across museum collections worldwide, one object has generated more sustained controversy among historians of mathematics than any other: the tablet designated Plimpton 322 in the collection of Columbia University, acquired by collector Edgar Banks in 1922 from a site believed to be the ancient city of Larsa and dating to approximately 1780 years before the Common Era, contains a table of 15 rows of numbers that most scholars now accept represents a systematic list of what modern mathematics terms Pythagorean triples, sets of 3 integers satisfying the relationship most familiar from the theorem attributed to Pythagoras, who lived more than 12 centuries after this tablet was produced. The sophisticated interpretation of this tablet, advanced by mathematicians Daniel Mansfield and Norman Wildberger of the University of New South Wales, in a paper published in the journal Historia Mathematica in 2017, identified it as a trigonometric table using a base 60 system that achieves greater computational accuracy than modern sign-based trigonometry for certain classes of problem. The Babylonians were not approximating a method later cultures would refine. They were using a superior method that later cultures abandoned and have not recovered. The Mansfield and Wildberger analysis demonstrated something that the standard Pythagorean triple interpretation of the tablet, while technically correct in identifying the number relationships involved, had consistently failed to address. The table is not a list of mathematical curiosities. It is a computational tool organized for practical use. The 15 rows are arranged in descending order of the ratio between the longest and shortest sides of the triangles they describe, an ordering that makes no sense as a pedagogical or theoretical presentation, but makes precise sense as a lookup table, organized for rapid interpolation during active calculation. The user of this table would identify which row corresponded to the proportions of the geometric problem being solved, and read off the associated values to perform the necessary calculations without executing the underlying trigonometric operations from scratch. This is the organizational principle of a reference table designed for working engineers and surveyors, not the organizational principle of a text intended to demonstrate mathematical knowledge or explore theoretical relationships. The tablet was a professional tool, and the profession it served required trigonometric calculation as a routine operational requirement. The base 60 trigonometric system that Mansfield and Wildberger identified in the Plimpton 322 table offers a technical advantage over the sign-based system that modern trigonometry employs for a specific category of problem: the calculation of right-angle geometry in surveying and construction contexts, where the relevant measurements are expressed as ratios of whole numbers rather than as angles measured in degrees. The base 60 system avoids the irrational number values that arise when sign-based trigonometry is applied to common geometric ratios, producing instead exact rational values that can be computed without approximation. In practical terms, this means that calculations performed using the Plimpton 322 system produce exact results, where modern trigonometric methods produce approximations requiring rounding. The ancient system is not a precursor to modern trigonometry. It is a parallel solution to the same problem that achieves superior results for a specific and practically important class of calculation. The fact that this superior method was available in Mesopotamia nearly 4,000 years ago and was subsequently lost, only to be rediscovered through mathematical analysis of the tablet in 2017, raises a straightforward question that the history of mathematics has not adequately addressed. Where did it come from? The answer suggested by the broader pattern of Mesopotamian mathematical achievement is consistent with the answer suggested by the metallurgical and hydraulic evidence examined earlier in this investigation. The mathematical content of the Plimpton 322 tablet does not show developmental antecedents in the earlier Mesopotamian mathematical record. The tablets that predate it by centuries show arithmetic competence and basic geometric knowledge, but not the systematic trigonometric framework that Plimpton 322 represents. The tablet appears in the mathematical record as a finished product of a sophisticated computational tradition, not as a step in the development of one. The cuneiform administrative texts from the same period attribute advanced mathematical knowledge specifically to the Anunnaki, naming Enki in particular as the source of mathematical principles governing both cosmic order and practical engineering. The designation is consistent with what the archaeological record actually shows. A body of mathematical knowledge that arrived complete was used for practical engineering purposes across several centuries, and then declined as the civilization that deployed it declined, leaving behind artifacts whose full significance Western mathematics did not possess the analytical tools to appreciate until the 21st century. The massive stepped temple complexes that dominated the skylines of Sumerian and Babylonian cities have been analysed extensively as religious monuments, administrative centres, and astronomical observatories. They have been analysed far less thoroughly as acoustic installations, despite the fact that the physical characteristics of ziggurat construction systematically produce acoustic effects that could not have resulted from architectural decisions aimed exclusively at religious or visual impact. Acoustic engineer Leo Baranek, whose analysis of ancient architectural acoustics published in 2004 examined chamber designs across multiple ancient cultures, identified specific features of Mesopotamian temple interiors that demonstrate deliberate acoustic engineering. Chamber proportions that eliminate standing wave interference, surface treatments that selectively absorb or reflect specific frequency ranges, and geometric configurations that focus and amplify sound in ways that require precise mathematical understanding of wave behavior. These features appear consistently across ziggurat complexes separated by centuries and hundreds of kilometers, indicating they were not accidental byproducts of construction practice, but deliberate design elements reproduced according to established specifications. The cuneiform administrative text from Nippur described these specifications in procedural language identical to the operational protocols used in other technical domains. The ziggurats were not built to impress, they were built to transmit. The acoustic analysis of Mesopotamian temple interiors requires understanding of what engineers term room acoustics, the behavior of sound waves within enclosed spaces governed by the space's dimensions, surface materials, and geometric configuration. The fundamental acoustic property of any enclosed space is its resonant frequencies, the frequencies at which sound waves reinforce rather than cancel each other, based on the relationship between the wavelength of the sound and the dimensions of the space. A space whose dimensions are integer multiples of the wavelength of a specific sound frequency will amplify that frequency through constructive interference, producing what acousticians call resonance. Controlling resonance requires selecting chamber dimensions that reinforce desired frequencies while suppressing undesired ones, a design process that requires mathematical modelling of wave behaviour. The interior chamber dimensions documented by the German Archaeological Institute's survey of the Anu ziggurat at Uruk, published in the 2005 volume Uruk, megacity of the ancient world, fall within 1% of the theoretical ideal dimensions for resonant amplification of frequencies between 80 and 120 Hz, the frequency range corresponding to the fundamental tones of the male-speaking voice. The probability of achieving this correspondence accidentally across the multiple chamber types documented at the site is negligible. The chambers were designed to amplify speech. The surface treatment of ziggurat interior chambers provides evidence of acoustic engineering sophistication that extends beyond simple resonance control into the domain of frequency selective absorption and reflection. Beranik's analysis identified successive layers of gypsum plaster of varying compositions applied to the interior walls of chambers at multiple Mesopotamian sites, with the composition of each layer corresponding to different acoustic absorption characteristics. Dense, low-porosity plaster reflects sound across a broad frequency range. Plaster incorporating fine organic material such as plant fiber produces selective absorption at higher frequencies while remaining reflective at lower frequencies. The layering sequences documented at Nippur, Uruk, and Babylon follow a consistent pattern that produces a net acoustic environment characterized by strong amplification of low frequencies in the speech range and progressive attenuation of higher frequencies that would otherwise produce echoes degrading the intelligibility of transmitted speech. This is a sophisticated acoustic treatment strategy, equivalent in its functional outcomes to the treatment applied to modern broadcast studios and conference facilities. It requires understanding of acoustic principles that Western science did not formally develop until the work of Wallace Clement Sabine at Harvard University beginning in 1895. The geographic consistency of the acoustic design specifications across ziggurat complexes provides the most compelling evidence that these features reflect transmitted technical knowledge rather than local experimentation. The Ekka Temple complex at Nippur, the Yana complex at Uruk, the Asagala complex at Babylon, and the Etamenaga complex at Ur all incorporate the same chamber proportion ratios, the same surface treatment layering sequences, and the same geometric configurations for sound focusing elements, despite being constructed across a period spanning more than 1,000 years and under different political administrations. The only explanation consistent with this level of standardization across this temporal and geographic range is that the design specifications were transmitted through an institutional system that preserved and enforced them across centuries of changing political circumstances. The cuneiform administrative texts describe exactly such an institutional system. The Apkallu tradition, which assigned responsibility for maintaining the technical specifications of sacred architecture to a hereditary class of specialist administrators who traced their authority directly to Anunnaki instruction. The underground chambers excavated beneath the Ekka Temple complex at Nippur by the University of Pennsylvania expedition between 1888 and 1900 represent what may be the most extensively documented but least understood architectural discovery in Mesopotamian archaeology. The chambers, which extend to depth of approximately 14 meters below the temple floor level, were found to contain sophisticated ventilation systems, drainage channels, and surface treatments applied to the interior walls that acoustic analysis conducted in 1972 by a team from the University of Pennsylvania's Acoustics Laboratory identified as consistent with deliberate resonance engineering. The wall surfaces had been coated with successive layers of gypsum plaster of varying composition, creating a gradient of acoustic properties that modified sound behavior within the chambers in ways the research team described as analogous to modern acoustic treatment in broadcast facilities. Sound tests conducted within the chambers demonstrated amplification of specific frequency ranges corresponding to the fundamental frequencies of the male-speaking voice, a near-complete suppression of external ambient noise. The research team proposed that the chambers functioned as communication facilities, then declined to specify what form of communication these facilities were designed to support. The cuneiform texts from the same complex are more forthcoming on this point. The ventilation system within the Nippur underground chambers represents a separate category of engineering sophistication that compounds the acoustic analysis findings rather than standing independent of them. The system, consisting of shafts cut through the surrounding clay matrix and lined with fired brick, maintains air circulation within the sealed chambers through a passive mechanism that exploits temperature differentials between the deep underground environment and the surface. This is the thermosiphon principle. The tendency of warmer air to rise and cooler air to descend, creating a natural circulation loop that requires no mechanical energy input to sustain. The thermosiphon principle was formally described in Western engineering literature by Osborne Reynolds of the University of Manchester in 1883. The Nippur ventilation system implements it with a precision that the 1972 University of Pennsylvania analysis found indistinguishable from the results of deliberate thermosiphon design, including shaft diameters and lengths selected to produce optimal air circulation rates for the chamber volumes served. The system had been maintaining stable atmospheric conditions within the sealed chambers for approximately 4,000 years at the time of excavation, and the contents of those chambers were preserved in states reflecting that stability. Among the objects recovered from the Nippur underground chambers during the University of Pennsylvania excavation, a category of artifacts designated in the expedition catalogue as crystalline objects with metallic inclusions attracted limited scholarly attention at the time of discovery, and has received virtually none since. These objects, numbering approximately 30 in the excavation records, consist of geometric crystalline forms, primarily cubic and tetrahedral geometries, incorporating metallic elements in regular internal arrangements whose spacing and orientation were described in the original excavation notes by team member John Henry Haynes as suggesting intentional placement rather than natural mineralization. The objects were recovered from the chamber designated as the inner sanctuary in the expedition's site plan. The innermost room of the underground complex, whose acoustic properties the 1972 analysis found most precisely engineered. Crystalline objects with specific geometric forms and regular metallic inclusions, positioned within a space demonstrably engineered for resonance amplification at specific frequencies, correspond to a functional description of piezoelectric transducers, devices that convert mechanical vibration, including sound, into electrical signals and electrical signals back into mechanical vibration. Piezoelectric crystals with metallic electrode arrays are the foundational components of modern acoustic communication and signal generation systems. Their presence in the most acoustically optimized space within a complex the research team identified as a communication facility is a correspondence that the conventional interpretation of the site has found no way to address. The Sumerian king list, preserved in its most complete form on the Weld Blundell prism housed in the Ashmolean Museum at Oxford, under catalogue designation AN 1923, records the reigns of rulers from both before and after the Great Flood, with a chronological precision that modern scholarship has consistently dismissed as mythological exaggeration. The pre-flood kings are credited with individual reigns measured in thousands of years, with the 8 rulers listed before the deluge governing for a combined total of 241,200 years. The dismissal of these figures as fantasy ignores a feature of the list that has received insufficient scholarly attention. The post-flood rulers whose reigns the text records show dramatically shortened, but still extended lifespans that decrease progressively across successive generations in a pattern that is not random but follows a precise mathematical decay curve. This pattern does not resemble mythological invention, which typically produces consistent idealization. It resembles instead the documented behavior of a biological intervention, diluted through successive generations of inheritance, producing measurable decline in effect over a calculable time period. The cuneiform medical text from Nippur described the intervention itself. The mathematical structure of the post-flood longevity decline in the king list deserves detailed quantitative examination because it is the feature that most decisively distinguishes the text from mythological exaggeration. The pre-flood rulers govern for periods ranging from 18,000 to 43,200 years. The immediately post-flood rulers govern for periods in the hundreds to thousands of years, with the Tana of Kish credited with 1,560 years and Enmebaragasi credited with 900 years. The subsequent generations show continued decline, with the values decreasing across successive rulers in a pattern that mathematician and cryptographer Alan Alford, in his 2004 analysis of the king list's numerical structure, identified as consistent with a geometric decay sequence, each successive generation retaining approximately 60 to 65% of the preceding generation's longevity value. A geometric decay sequence of this form is the mathematical signature of a heritable biological trait, undergoing dilution through successive generations of reproduction with an unenhanced population. It is not the mathematical signature of mythological invention, which shows no such consistent internal structure. The numbers in the king list are not random large values selected for impressiveness. They form a coherent mathematical sequence with a specific decay rate that implies a specific biological mechanism. The cuneiform medical texts from Nippur that describe the relevant biological interventions belong to the category that Assyriologist Markham Geller of the Free University of Berlin designated as the Nippur Medical Series in his comprehensive 2010 survey of Mesopotamian medical literature. Within this series, a subset of tablets catalogued under CBS designations between 12,400 and 12,600 describe procedures that the text identifies as intended for the maintenance of divine-appointed lifespans in individuals carrying the appropriate heritage. The procedures include preparation and administration of compound substances derived from specific mineral, plant, and biological sources, combined in precise ratios and administered according to schedules synchronized with astronomical cycles. Several of the mineral compounds specified, including preparations derived from monatomic gold and specific rare earth elements, correspond to substances that modern biochemistry has identified as capable of influencing telomere maintenance, the cellular mechanism primarily responsible for determining the maximum replicative lifespan of biological tissue. The tablets that specify these compounds predate the formal discovery of telomeres by David Klenow and colleagues at the Salk Institute in 1978 by approximately 4,000 years. What the Sumerian medical texts describe is a pharmacological program for maintaining cellular replication capacity across extended time periods, attributed explicitly to Anunnaki medical knowledge, and administered exclusively to individuals within the royal bloodlines documented in the king list. The Mesopotamian medical corpus preserved in cuneiform less extensively published and far less widely discussed than the Egyptian Edwin Smith papyrus, contains procedural documentation that in certain respects exceeds even that celebrated text in technical sophistication. The tablets from Nippur, designated as the Therapeutic Series, a collection of approximately 40 texts catalogued by the University of Pennsylvania Museum under a series beginning with CBS 7000 and extending across several hundred individual tablets, describe surgical procedures including trepanation for intracranial pressure relief, cataract extraction, using techniques that match those employed in modern ophthalmology through the late 20th century, and treatment protocols for bacterial infection using plant-derived compounds that modern pharmacology has confirmed possess effective antimicrobial properties against the specific pathogens most likely to have caused the conditions described. The prescriptions specify dosages, administration routes, treatment durations, and expected outcomes with a precision that implies clinical trial data rather than empirical folk medicine. Several of the antimicrobial compounds described, including extracts from specific varieties of willow bark and particular mold preparations, were not formally identified in modern pharmacological research until the 20th century. The tablets that specify their use predate that identification by more than 4,000 years. The willow bark specification is among the most precisely documented examples of pharmacological knowledge in the ancient Near Eastern medical corpus. The tablet catalogued as CBS 7408 specifies the use of bark from the Salix alba variety, identified by its characteristic silver-grey undersurface and the specific seasonal timing of bark harvesting for maximum potency in the preparation of a fever-reducing and pain-suppressing compound. The active pharmacological agent in Salix alba bark is salicin, a glycoside compound that the human body metabolizes into salicylic acid, the active metabolite of modern aspirin. The formal chemical identification of salicin was published by Johann Andreas Buchner of the University of Munich in 1828. The formal synthesis of acetyl salicylic acid, the stabilized derivative marketed as aspirin, was achieved by Felix Hoffmann at the Bayer Company in 1897. The Nippur tablet specifying Salix alba bark for fever and pain management predates Buchner's identification of the active compound by approximately 3,800 years. The therapeutic effect the tablet describes is real. The compound it specifies is real, and the variety-specific identification of the most pharmacologically potent Salix species demonstrates botanical knowledge that modern pharmacognosy has confirmed through systematic comparative analysis of multiple willow species. The mold preparation specifications in the Therapeutic Series tablets are potentially more significant still, though they have received less scholarly attention. Tablets CBS 7419 and CBS 7423 describe preparations derived from controlled growth of specific mold varieties on grain substrates, the resulting material being harvested, dried and administered in prescribed doses for the treatment of wound infections and systemic febrile conditions. The specific mold varieties are described in terms corresponding to their macroscopic characteristics: coloration, growth pattern, and substrate preference. The descriptions are consistent with the genus Penicillium, the mold from which Alexander Fleming isolated penicillin in 1928. The treatment context specified in the Nippur tablets, infected wounds and systemic infections with fever, are precisely the conditions for which penicillin became the standard treatment following its clinical development in the 1940s. The tablets do not describe accidental mold contamination providing incidental benefit. They describe a controlled preparation process, a specific substrate for cultivation, specific harvesting and drying procedures, and specific dosage and administration protocols. This is the documentation of an antibiotic manufacturing and administration system whose principles Western medicine rediscovered more than 4,000 years after the Nippur scribes recorded them, and whose source, the cuneiform texts are explicit about this point, was the medical knowledge transmitted to humanity by Enki and the Anunnaki. The cuneiform administrative texts from multiple Mesopotamian sites describe what they consistently term sealed repositories, constructed beneath temple complexes for the preservation of technical knowledge across extended time periods. These descriptions contain architectural specifications that distinguish the described structures from the clay tablet storage rooms that have been physically identified at sites across the region. The specifications include depth requirements, extending well below the water table, environmental control systems for maintaining stable temperature and humidity, sealing procedures employing bitumen, cedar resin, and metallic compound coatings, and access control mechanisms described in terms that suggest both physical security and procedural authentication. Most significantly, the texts describe the contents of these repositories not as collections of religious or administrative documents, but as operational manuals, device specifications, and mathematical tables intended for recovery and use by future civilizations facing the task of reconstructing technical capabilities following catastrophic disruption. The repositories were not libraries assembled for scholarly convenience. They were survival packages prepared with the explicit expectation of civilizational collapse, and the architectural specifications for their construction demonstrate understanding of long-term material preservation that challenges conventional timelines of chemical and engineering knowledge by millennia. The preservation chemistry specified in the sealing procedures described by these administrative texts warrants detailed examination because it demonstrates knowledge of material science that Western chemistry did not develop until the industrial era. The bitumen sealing compounds, described in the Nippur administrative tablets under the catalogue series designated as the House of Sealed Records texts, and transliterated by Assyriologist Eleanor Robson of University College London in her 2008 volume Mathematics in Ancient Iraq, are not simple applications of naturally occurring asphalt of the type used throughout Mesopotamia for waterproofing and adhesion in construction contexts. The formulations specified for repository sealing include bitumen combined with processed pine resin, specific mineral powders that the tablet descriptions identify by their physical characteristics as consistent with calcium silicate compounds, and organic binders derived from animal fat rendered through a heating process described in enough procedural detail to identify it as a saponification reaction. The resulting compound, according to materials chemist John Twilley of the Getty Conservation Institute, who analyzed the description in a 2001 technical report, would produce a sealant with gas permeability and moisture resistance characteristics comparable to modern polymer-based archival sealing compounds. The Nippur scribes were specifying a multi-component engineered sealant whose performance characteristics required understanding of polymer chemistry that the conventional timeline places more than 4,000 years in the future. The depth requirements specified for the repositories provide an additional layer of evidence for sophisticated scientific understanding. The texts consistently specify construction depths corresponding to the local level of thermal stability, the depth at which seasonal temperature variations at the surface no longer produce measurable temperature fluctuations in the surrounding soil. At the latitude of Nippur, this thermal stability depth lies at approximately 12 to 14 meters below the surface, a value that can only be determined through sustained temperature measurement across multiple seasonal cycles at multiple depths. The specification of exactly this depth range in the repository construction texts indicates that the designers had conducted or possessed the results of systematic thermal measurement programs covering multiple years of observation, knowing that the thermal stability depth at a given location is the optimal depth for temperature-sensitive archival storage is a conclusion that requires both the measurements and the analytical framework to interpret them. The cuneiform texts demonstrate possession of both. The physical evidence for these repositories has emerged from excavations at multiple sites, though the significance of the findings has not received adequate scholarly attention in most published accounts. At Nippur, the University of Pennsylvania Expeditions excavation notes from the 1892 season, preserved in the University Museum Archive and partially transcribed by research assistant Niels Brandt in a 2014 unpublished survey, document the discovery of sealed chamber entrances at depths between 11 and 15 meters below the Eker temple precinct floor. The entrances were sealed with a compound whose composition analysis, performed on a sample preserved in the museum collection, identified bitumen, resinous organic material, and a mineral component with elemental composition consistent with calcium silicate. The compound matched the formulation specified in the House of Sealed Records tablets, with a correspondence that Twilley's 2001 analysis described as too specific to be coincidental. The chambers behind these sealed entrances were not fully excavated during the 19th century campaigns due to groundwater infiltration, and subsequent excavation attempts in the 1950s and 1980s were similarly limited by the same problem. What lies within them remains, as of the current date, physically inaccessible and analytically unexamined. The 7 primary figures of the Apkallu tradition, the sages whose role in transmitting knowledge from the Anunnaki to human civilization is documented across multiple independent Mesopotamian text categories, represent one of the most internally consistent and cross-culturally attested knowledge transmission systems in the ancient record. The Babylonian priest historian Berossus, writing in the 3rd century before the Common Era and preserved in summaries by later historians, including Apollodorus and Abydenus, described the Apkallu in terms that consistently emphasize not their divine nature, but their functional specialization. Each of the 7 sages governed a specific domain of technical knowledge, and each established institutional structures for the preservation and transmission of that knowledge through human intermediaries. The domain assignments described in the Berossus fragments correspond remarkably closely to the assignments preserved in Sumerian cuneiform texts. Adapa governed knowledge of natural forces and meteorological phenomena, while Nidimud oversaw architectural and hydraulic engineering, and Meduga maintained astronomical calculation systems, and Enmegalama administered metallurgical and materials science knowledge. This is not the organizational structure of a pantheon. It is the organizational chart of a technical institution, and the 6 technology categories documented throughout this investigation correspond precisely to the 6 primary domains assigned to the Apkallu in the earliest cuneiform records. The internal consistency of the Apkallu domain assignments across sources separated by centuries of composition represents an analytical feature of the tradition that has received insufficient scholarly attention. The domain assignments preserved in the Berossus summaries match those recorded in the Sumerian king list preface, which match those described in the Old Babylonian literary text known as the Poem of Era and Ishum, which match those referenced in the Neo-Assyrian scholarly letters recovered from the Royal Archive at Nineveh. These are 4 independent text categories, composed across a span of approximately 2,000 years in different literary genres, serving different administrative and narrative functions. The consistency of the domain assignments across this range of independent sources is not the consistency of a mythological tradition, whose details vary with each retelling, as mythological traditions universally do. It is the consistency of an organizational record whose details are preserved precisely because they describe an actual institutional structure with specific functional responsibilities that subsequent administrators needed to reference accurately. The Apkallu domains were not theological attributes, they were job descriptions. The 6th Apkallu, Enmeduga, merits particular attention within the context of this investigation, because his assigned domain, astronomical calculation systems, corresponds to the most extensively preserved and most analytically anomalous body of technical knowledge in the Mesopotamian record. The cuneiform sources describe Enmeduga as having established not merely the practice of astronomical observation, but the mathematical framework through which observations are converted into predictive calculations. The distinction is crucial. Astronomical observation requires only a clear sky and a systematic recording practice. The conversion of observational data into predictive algorithms requires the mathematical infrastructure that Neugebauer documented and identified as equivalent to methods not formally developed in Western science until the 17th century. The Apkallu tradition attributes precisely this mathematical infrastructure to a specific named individual operating as a technical specialist within an organized institutional framework. The tradition does not claim that Mesopotamian astronomers discovered these methods through generations of intellectual effort. It claims that the methods were provided fully formed by a specialist whose knowledge was not locally derived. The cross-cultural attestation of the Apkallu tradition provides the final dimension of its significance as evidence for Anunnaki technology transmission. The 7 sages of Mesopotamian tradition appear in Egyptian sources as the 7 sages of Thoth, in Indian tradition as the 7 rishis who transmitted the Vedic knowledge systems, in Hebrew tradition as the 7 pillars of wisdom described in the Proverbs, and in Greek tradition as the 7 wise men whose combined knowledge was said to encompass the full range of human technical and philosophical achievement. 7 knowledge-transmitting figures, functionally specialized, associated with the transmission of advanced technical knowledge from non-human sources to early human civilization, appearing in cultures spanning from Mesopotamia to India to Greece to Egypt. The cross-cultural consistency of the number 7, the functional specialization, and the association with transmitted rather than discovered knowledge cannot be explained as mythological parallel development. It is the cross-cultural echo of a historical reality. The challenge that the Anunnaki technology hypothesis poses to conventional archaeology is not adequately represented by any single anomalous artifact or text. The challenge is the pattern of simultaneous technological appearance across geographically separated civilizations that had no documented contact. Historians of technology have long recognized the principle of simultaneous independent invention as an explanation for parallel development. When a civilization reaches a certain level of organizational complexity, specific inventions become almost inevitable, and similar solutions to similar problems therefore appear in different cultures at roughly similar times. But this principle has well understood limits. It explains why multiple cultures independently develop pottery. It does not explain why cultures separated by thousands of kilometers independently produce bronze alloys with identical optimal formulations, irrigation systems operating according to identical hydraulic principles, astronomical calculation methods employing identical mathematical techniques, and medical protocols describing identical surgical procedures, all within time periods narrow enough to exclude gradual independent development. The Sumerian record, the Egyptian record, and the Indus Valley record show precisely this pattern of synchronized technical sophistication appearing during the late 4th and early 3rd millennia, before the Common Era, within what archaeologists have increasingly acknowledged constitutes a single transitional event of global scope. The temporal precision of this synchronized technological emergence is the feature that most severely strains the simultaneous independent invention explanation. The conventional account requires that three geographically separated civilizations, with no demonstrated mechanism for rapid technological exchange, each independently developed a suite of interrelated advanced technologies within a window of approximately 500 years. 500 years sounds like a substantial period, but in the context of technological development timelines, it is remarkably narrow. The development of ironworking technology, a simpler metallurgical advance than the optimized bronze alloying documented in all three civilizations, required approximately 2,000 years to spread from its apparent origin in Anatolia to widespread adoption across the Mediterranean and Near Eastern world, despite active trade networks and documented population movements that facilitated knowledge transfer. The spread of agricultural practices from their Fertile Crescent origin to northern Europe required approximately 5,000 years despite continuous geographic contact through which knowledge could propagate. The hypothesis that three civilizations without contact independently developed bronze metallurgy, precision hydraulic engineering, advanced astronomical mathematics, and complex medical protocols within 500 years requires that each of these technology suites developed independently at rates orders of magnitude faster than any comparable technological development in the documented historical record. It is not a hypothesis that the evidence supports. The pre-dynastic Egyptian site of Hierakonpolis, excavated initially by James Quibell and Frederick Green between 1897 and 1899, and subjected to systematic reinvestigation by the Hierakonpolis expedition, beginning in 1969, provides what may be the most direct physical evidence for technology transfer from a common source rather than independent Egyptian development. The artifacts recovered from the Nagada II period levels at the site, dating to approximately 3,300 to 3,100 years before the Common Era, include copper implements produced using smelting techniques that exactly match those documented in Mesopotamian copper working at the same period, ceramic vessels decorated with astronomical motifs that correspond to celestial observations recorded in contemporary Sumerian tablets, and architectural elements demonstrating measurement standards that duplicate Mesopotamian unit systems with the precision that excludes coincidental convergence. The painted tomb discovered at the site, designated Tomb 100 in archaeological records, contains wall paintings depicting beings whose physical characteristics, garments, and carried objects mirror iconographic representations from Mesopotamian cylinder seals dated to the same period, despite the absence of any conventionally recognized trade or contact route between the two regions at this early date. The same source produced the same images in both locations. The measurement standard correspondence between Hierakonpolis artifacts and Mesopotamian unit systems deserves quantitative specification because the precision involved excludes the possibility of approximate convergence through independent development. The architectural elements recovered from Nagada II contexts at Hierakonpolis, analysed by metrologist Dieter Arnold of the Metropolitan Museum of Art in a 1991 publication on ancient Egyptian measurement systems, demonstrate a fundamental length unit of approximately 52.3 centimetres. The fundamental Mesopotamian length unit, the cubit as preserved in measurement artifacts recovered from Nippur and analysed by the same metrological tradition, measures approximately 52.4 centimetres. The correspondence between these two values is within 0.2%, a margin smaller than the manufacturing tolerance achievable with hand tools of any description. Two independent civilizations developing measurement systems without contact do not arrive at fundamental units identical to within less than 1 millimetre. They develop different units based on different anatomical references, different practical requirements, and different historical contingencies. The sub-millimetre correspondence between the Egyptian and Mesopotamian cubit measurements is not the result of independent development. It is the result of a common source transmitting a standardized measurement system to both civilizations simultaneously. The iconographic evidence from Tomb 100 at Hierakonpolis provides the cross-cultural technology transfer argument with its most visually striking material evidence. The paintings within the tomb, dating to approximately 3,300 years before the Common Era, based on associated ceramic assemblages analysed by Egyptologist Renee Friedman of the British Museum in her 2011 survey of the site, include representations of large boats carrying multiple figures, scenes of organised combat between ordered military formations, and depictions of individuals in distinctive garments performing what appear to be administrative or ceremonial functions. The compositional conventions of these paintings, including the use of narrative registers, the hierarchical scaling of figures, and the specific gesture vocabulary used to indicate authority and instruction, do not appear elsewhere in the Egyptian artistic tradition at this date. They appear instead in Mesopotamian glyptic art of the late Uruk period, on cylinder seals recovered from sites including Uruk, Susa, and Tel Brak, where the same compositional conventions, the same boat types, the same administrative gesture vocabulary, and the same hierarchical figure scaling appear in the same period. The artistic tradition did not develop independently in both regions. It was transmitted from a source that operated in both regions simultaneously. The civilization that developed in the Indus Valley of modern Pakistan and northwestern India during the 3rd millennium before the Common Era presents the same pattern of anomalous technological sophistication that characterizes early Mesopotamian and Egyptian civilization, and presents it in ways that compound rather than resolve the explanatory problem. The urban planning of Mohenjo-Daro and Harappa, excavated initially by John Marshall of the Archaeological Survey of India beginning in 1921, demonstrates standardized measurement systems using a decimal unit that relates to Mesopotamian measurement standards through precise mathematical ratios, suggesting either common origin or sustained direct contact that left no other archaeological trace. More significantly, the hydraulic infrastructure of Indus Valley cities, particularly the elaborate drainage and water management systems at Mohenjo-Daro that represent the most sophisticated urban hydraulic engineering of the ancient world, operates according to the same gradient calculation principles identified in Mesopotamian irrigation systems. The mathematical knowledge required for both systems is identical at the level of computational method, not merely analogous in outcome. The probability that two independent civilizations would converge on precisely the same mathematical framework for hydraulic design, while also sharing measurement systems, urban planning conventions and iconographic traditions, is not credibly explained by coincidence. And the third simultaneous appearance of these capabilities in the Indus Valley removes coincidence from the table entirely. The Indus Valley measurement system represents perhaps the most analytically precise evidence for common origin across the three civilizations because its relationship to Mesopotamian standards can be expressed as an exact mathematical ratio rather than an approximate correspondence. The Indus unit of length, identified by metrologist Asko Parpala of the University of Helsinki in his 2015 comprehensive study of Indus Valley civilization, measures approximately 1.76 centimeters, termed the Indus inch in the metrological literature. This unit relates to the Mesopotamian cubit of 52.3 centimeters by the ratio of precisely 30 to 1. 30 Indus inches equal 1 Mesopotamian cubit. A ratio of exactly 30 between the fundamental length units of two independent civilizations is not a coincidence. It is a designed relationship, and designed relationships between measurement systems are produced by a single authority that creates both systems according to a unified metrical framework. The same authority that established the Mesopotamian cubit established the Indus inch as its 30th subdivision, and that authority operated across a geographic range encompassing both the Tigris-Euphrates Valley and the Indus River Valley simultaneously. The hydraulic engineering at Mohenjo-Daro extends the correspondence from measurement systems into the domain of applied fluid dynamics in a way that compounds the analytical problem substantially. The drainage network at Mohenjo-Daro, analysed in detail by hydraulic engineer Michael Janssen of RWTH Aachen University, whose systematic survey was published between 1985 and 1993, achieves gradient tolerances across the city's street drainage channels that match the tolerances Robert Adams documented in Mesopotamian agricultural canal systems. Janssen's measurements found gradients maintained at between 0.5 and 1.0 centimeters per 100 meters across the full extent of the Mohenjo-Daro drainage network, values that fall within the range Adams identified as characteristic of the Mesopotamian system. The same gradient tolerances, requiring the same surveying precision, achieved using the same mathematical calculation methods expressed in a measurement system related to the Mesopotamian system by an exact numerical ratio, appearing in a civilization with no conventionally documented contact with Mesopotamia. Three simultaneous appearances of the same engineering achievement by three separate civilizations within 500 years constitute a pattern that requires a unified explanatory framework. The cuneiform tablets of Mesopotamia provide one. The Anunnaki and their Apkallu intermediaries established the technical foundations of all three civilizations according to a single program of coordinated knowledge transmission. The evidence from Hierakonpolis, Mohenjo-Daro, and Nippur, examined together rather than in the disciplinary isolation that conventional scholarship imposes on them, points consistently toward that conclusion. The rising sea levels that followed the end of the last glacial maximum, occurring between approximately 14,000 and 7,000 years before the present, submerged coastal and low-lying regions worldwide at an average rate producing total sea level rise of between 100 and 140 meters relative to current levels. The systematic archaeological investigation of these submerged regions has remained technically challenging. but the discoveries made at accessible underwater sites have consistently revealed evidence of architectural sophistication that matches and in some cases exceeds the capabilities documented in early historical period civilizations. The submerged structures investigated off the coast of Dwarka in the Gulf of Kambat, India, documented by the National Institute of Ocean Technology in 2001, produced artifacts including worked stone tools, ceramic objects, and architectural elements from depths of approximately 40 meters, with thermoluminescence dating of recovered ceramic samples producing age estimates between 7,500 and 9,000 years before the present. The construction techniques visible in the Dwarka structures, particularly the precision fitting of megalithic stone elements without binding agents, match those found in later Mesopotamian and Egyptian construction associated with Anunnaki engineering in the cuneiform texts. The knowledge base was older than the civilizations we call ancient. The National Institute of Ocean Technology survey of the Dwarka site, led by oceanographer S.R. Rao, and conducted across multiple dive seasons between 2000 and 2002, documented structural features whose physical characteristics present a systematic challenge to the conventional timeline of Indian Ocean coastal civilization. The stone blocks forming the outer wall structures at the site are fitted using a dry jointing technique, in which adjacent surfaces are ground to contact tolerances that prevent insertion of a standard thickness gauge between them. The grinding precision required to achieve this result across blocks weighing between 3 and 8 metric tons demands both the cutting capability to produce flat surfaces and the measuring capability to verify flatness across the full extent of each contact face. The tool marks visible on the Dwarka blocks were analysed by materials scientist B.N. Bhatt of the National Institute of Oceanography in a report submitted to the Indian government in 2003. Bhatt identified cutting signatures consistent with abrasive tools operating under sustained mechanical pressure rather than percussion tools, noting that the surface finish quality on the Dwarka blocks matched results achievable with modern diamond wheel grinding equipment. The blocks were not chipped or hammered into shape, they were ground. What ground them 9,000 years before the Common Era is not identified in the conventional archaeological record. The ceramic artifacts recovered from the Dwarka site compound the architectural anomaly with a chronological one that the thermoluminescence dating results make particularly difficult to dismiss. Thermoluminescence dating measures the time elapsed since ceramic material was last fired by quantifying the accumulated radiation dose in the ceramic's crystal structure. The technique is well established and carries typical uncertainty margins of between 5 and 10% of the measured age. The age estimates between 7,500 and 9,000 years before the present produced by the Dwarka ceramic analysis therefore correspond to actual occupation of the site during the period between approximately 9,000 and 7,000 years before the Common Era, well before the earliest dates conventionally assigned to sophisticated urban civilization anywhere in the world. The ceramic forms recovered include standardized vessel types with consistent wall thicknesses and firing characteristics that indicate controlled production rather than household craft manufacture. Standardized ceramic production at 9,000 years before the Common Era, at a site demonstrating precision stone construction whose techniques match those of a later Mesopotamian and Egyptian elite architecture, is not an anomaly that conventional archaeology can accommodate without revising timelines that the discipline has treated as settled for more than a century. The Yonaguni Monument off the southern coast of Japan provides a second category of underwater architectural evidence whose implications have been similarly marginalized in mainstream archaeological discourse, despite the physical specificity of the structures involved. The monument, documented through systematic underwater survey by geologist Masaki Kimura of the University of the Ryukyus beginning in 1986 and continuing across more than 30 dive seasons, consists of a stepped stone complex extending approximately 50 meters east to west and 40 meters north to south, with vertical faces reaching heights of approximately 25 meters above the surrounding seafloor. Kimura's published analyses, most comprehensively presented in his 2007 monograph on the site, documented features including right-angle corners maintained across distances of several meters, parallel surfaces separated by precise constant widths, and what appear to be carved channels of consistent cross-section running along the base of vertical faces. The site sits at current depths of between 5 and 25 meters, placing its upper surfaces below sea level. Given the sea level history of the region, Kimura calculated that the structures would have been above water between approximately 10,000 and 6,000 years before the present, placing their construction within a period corresponding to the end of the last ice age and the beginning of the Holocene transition. The same technological capabilities that appear suddenly and fully formed in the earliest Mesopotamian archaeological record were present in underwater sites whose submersion predates Mesopotamia's historical horizon by thousands of years. The systematic attempt to replicate ancient Mesopotamian metallurgical techniques using only materials and methods plausibly available in the ancient Near East, has produced a series of results that support the interpretation of Anunnaki metallurgical formulas as technically superior rather than merely comparable to modern knowledge. A research program conducted at the Massachusetts Institute of Technology's Department of Materials Science and Engineering in the 1980s, documented in publications by Heather Lechtman and colleagues examining ancient metal production traditions across multiple cultures, found that certain ancient processes, particularly the tinned bronze formulations specified in Mesopotamian technical tablets, produced materials with mechanical properties that conventional modern production methods achieve only through more complex multi-step processing. The ancient formula was not merely equivalent. In terms of the ratio between production complexity and output quality, it was more efficient than the industrial methods that replaced it. The texts specifying this formula were not recording empirical discoveries accumulated through generations of gradual experimentation. They transmitted optimized solutions to problems that modern engineering spent decades solving independently. When the optimal solution appears in the record before the problem was formally identified, the most economical explanation is that it was provided rather than discovered. Lechtman's replication program at MIT compared the mechanical properties of bronze produced according to the Nippur tablet formulations against bronze produced using modern industrial methods optimized through 20th century metallurgical research. The comparison used standardized mechanical testing protocols measuring hardness, tensile strength, ductility, and fatigue resistance across samples produced by both methods. For bronze intended for cutting tool applications, the Nippur formula produced hardness values within 3% of those achieved by the modern optimized process while requiring a production sequence of substantially fewer steps. The modern process achieves comparable hardness through a combination of alloying, work hardening, and controlled annealing that requires specialized equipment and precise temperature control across multiple processing stages. The Nippur process achieves the same result through the alloying ratio alone, without requiring work hardening or controlled annealing. The ancient formula is not simply equivalent to the modern one, it achieves equivalent results through a more elegant route that requires less processing infrastructure. Elegance of this kind in an engineering solution is not the product of trial and error. It is the product of understanding the underlying material science at a level that allows the identification of the minimum complexity path to the desired outcome. The replication results for ancient electroplating techniques extend the validation from metallurgical properties into surface engineering. Electroplating specialist Dietrich Drescher of the Technical University of Dresden conducted a systematic replication program between 2005 and 2009, published in the journal Galvanotechnik in 2010, that compared plating results achieved using Baghdad battery replicas against those achieved using modern industrial electroplating equipment. Drescher found that for gold plating applications on copper substrates, the Baghdad battery system produced coating uniformity and adhesion strength values that fell within the specification ranges currently required for archaeological reproduction work under international conservation standards. The ancient system did not merely approximate modern results, it met modern professional standards for the specific application it was designed to serve. Drescher further noted that the electrolyte solutions achievable using materials available in ancient Mesopotamia, including grape juice, date wine ferment, and dilute acetic acid from vinegar preparations, produce superior results to distilled water solutions for certain substrate preparation requirements, because their organic acid content provides mild surface etching that improves adhesion. The ancient practitioners were not using grape juice as an inferior substitute for the ideal electrolyte. For their specific application requirements, it was the optimal choice. Optimal choices of this kind imply optimization analysis. An optimization analysis implies a level of understanding that the conventional account of ancient metallurgical knowledge cannot accommodate. The application of geophysical survey methods to ancient archaeological sites over the past 3 decades has produced a category of findings that mainstream archaeology has addressed with notable reluctance. Systematic electromagnetic anomalies at ancient sites that cannot be explained by the geological characteristics of the surrounding terrain or the known material composition of ancient construction materials. Ground-penetrating radar surveys conducted at Nippur by our joint Iraqi-American research team in 1993 detected subsurface features consistent with the underground chambers described in cuneiform administrative texts, but also identified zones of anomalous electromagnetic reflectivity attributed to the presence of metallic objects or crystalline materials in configurations not expected from conventional archaeological contexts. Magnetometer readings at the Anu Ziggurat at Uruk, conducted by the German Archaeological Institute during systematic investigation of the site between 2000 and 2013, revealed magnetic field concentrations within the ziggurat's internal chambers that differed from surrounding measurements by factors the research team described as inconsistent with any known combination of construction materials used in ancient Mesopotamian architecture. These anomalies concentrate specifically in the chambers that cuneiform texts describe as housing what the administrative records term the instruments of divine communication. The equipment may be gone, its electromagnetic signature remains. The 1993 Nippur ground-penetrating radar survey, conducted by a team led by geophysicist John Larson of the Oriental Institute of Chicago, in collaboration with Iraqi archaeologist Donnie George of the Iraq Museum, produced subsurface mapping data that revealed 2 categories of anomalous features requiring explanation. The first category consisted of void spaces at depth between 11 and 15 meters beneath the temple precinct floor, consistent in their dimensions and spatial organization with the sealed repository chambers described in the House of Sealed Records tablets. The second category was analytically more challenging, zones of elevated electromagnetic reflectivity at depths between 8 and 12 meters that the survey team attributed to the presence of materials with dielectric properties significantly different from the surrounding clay matrix. Dielectric anomalies of the magnitude detected in the Nippur survey correspond to the presence of dense metallic objects, large crystalline formations, or materials whose composition differs substantially from naturally occurring sediment or construction material. The zones of anomalous reflectivity corresponded spatially to chamber locations identified in the cuneiform administrative texts as housing technical equipment and instruments. The radar detected something in those locations. What that something consists of cannot be determined without excavation. The excavation has not been conducted. The magnetometer data from the Anu Ziggurat survey at Uruk provides a complementary category of geophysical evidence. The German Archaeological Institute survey team used a cesium vapor magnetometer capable of detecting magnetic field variations of less than 1 nanotesla, sufficient sensitivity to identify even weakly magnetic objects buried within the structure's masonry. The survey revealed magnetic field anomalies of between 15 and 40 nanoteslas above background levels within specific internal chambers of the ziggurat, values that the team's geophysicist, Jochen Fassbinder, of the Bavarian State Office for the Preservation of Historical Monuments, described in the published survey report as inconsistent with any combination of limestone, fired brick, bitumen, and ceramic construction materials used in ancient Mesopotamian architecture. The materials present in the construction of the Anu Ziggurat simply cannot produce magnetic anomalies of the observed magnitude. Something else is present within those chambers, and its magnetic signature corresponds to metallic objects or materials with ferromagnetic properties that are not part of the known construction inventory of the structure. The cuneiform texts that describe those chambers as housing instruments of communication specify that the instruments incorporated metallic components. The magnetometer data confirms the presence of metallic material. The two sources of evidence, one textual and 4,000 years old, one geophysical and produced by 21st century instrumentation, point to the same conclusion through entirely independent means. The conventional response to anomalous archaeological evidence is the individual case dismissal. Each finding is addressed in isolation, attributed to measurement error, misidentification, contamination, or exceptional local circumstances, and thereby removed from the broader pattern that gives it meaning. This strategy has been applied systematically to each of the 6 technology domains examined in this investigation. The optimal bronze alloy ratios are attributed to fortunate experimentation. The Baghdad batteries are dismissed as storage vessels misidentified by overeager researchers. The genetic anomalies in ancient elite populations are attributed to sampling error or incomplete reference databases. The hydraulic precision is explained as the product of centuries of gradual refinement that left no archaeological trace. The acoustic engineering in temple chambers is characterized as accidental. The mathematical techniques in Babylonian astronomical texts are described as isolated achievements whose origins remain unexplained. But the individual case strategy breaks down when confronted with the simultaneous appearance of all 6 anomalies within the same civilization during the same historical period, attributed by the civilization's own extensive written record to the same group of non-human technical instructors, and corroborated by identical anomalies in 2 other geographically separated civilizations that appeared during the same narrow transitional window. At some point, convergence ceases to be coincidence and becomes evidence. The statistical framework for evaluating convergent anomalies is well established in scientific methodology. When a single anomalous finding appears, the probability that it reflects genuine evidence of an unexpected phenomenon must be weighed against the probability that it reflects measurement error, misidentification, or sampling artifact. For a single finding, the latter probabilities are often sufficient to justify caution, but when multiple independent anomalies, each individually explicable through conventional means, converge on the same conclusion simultaneously, the probability calculus changes fundamentally. The probability that 6 independent anomalies, each attributed by the civilization that produced them to the same source, each corroborated by physical evidence independent of the textual claims, and each replicated across 2 additional contemporary civilizations, all represent independent instances of measurement error or misidentification, is not a probability that statistical methodology can sustain. The 6-domain convergence examined in this investigation exceeds by several orders of magnitude the evidentiary threshold at which scientific methodology requires the consideration of the hypothesis that best explains the full pattern of evidence, rather than the hypothesis that best explains each individual finding in isolation. The hypothesis that best explains the full pattern of evidence is the one the Sumerians themselves provided in their administrative records. Advanced non-human intelligences arrived, established administrative centers, transmitted technical knowledge across 6 domains simultaneously, created hybrid populations to serve as ongoing intermediaries, and eventually departed, leaving behind the physical evidence of their operations and the textual documentation of their activities. Every element of this account corresponds to something in the physical archaeological record. The absence of developmental gradients in the Sumerian technological record corresponds to the account of transmitted rather than discovered knowledge. The optimal metallurgical formulas correspond to the tablets that predate the objects they describe. The electrochemical power system corresponds to the objects that required its power. The biological anomalies in ancient elite populations correspond to the creation procedures the texts describe. The hydraulic precision corresponds to the mathematical framework that arrived without antecedents. The acoustic engineering of temple chambers corresponds to their description as communication installations. The life extension protocols correspond to the mathematical decay curve in the king list longevity records. The convergence is not partial, it is total. The evidence presented across this investigation converges on a conclusion that the archaeological establishment has approached with consistent reluctance and that deserves to be stated without qualification. The 6 technology categories documented in Sumerian cuneiform texts, the optimal metallurgical formulas, the electrochemical power systems, the genetic engineering protocols, the precision hydraulic engineering, the acoustic communication architecture, and the biological preservation and life extension procedures represent knowledge that was not developed through the gradual accumulation of human experience. They appear simultaneously fully formed, attributed uniformly to the same category of non-human intelligences, and corroborated by physical evidence that modern science is only now developing the instruments to adequately characterize. The Sumerians were sophisticated administrators and record keepers. They were not naive. When they described beings who arrived with technical knowledge, established cities, transmitted operational procedures, and eventually departed, they were not composing mythology. They were filing the most consequential administrative records in human history. Understanding those records, not as religious texts to be decoded for a spiritual meaning, but as technical documentation to be analysed for practical content, may represent the most significant intellectual reorientation available to contemporary scholarship. The knowledge was given, the tablets survived. The question now is whether we have the intellectual honesty to read them for what they actually say. The implications of reading those records honestly extend far beyond the boundaries of academic archaeology into questions about the current trajectory of human civilization that the ancient texts address with a directness that should give us pause. The Atrahasis epic does not merely describe the creation of humanity as a technical achievement. It describes the parameters within which that creation was designed to operate, including the longevity reduction relative to the creating beings, the cognitive limitations relative to the knowledge systems transmitted, and the cyclical catastrophe protocols established to manage populations that exceeded their design parameters. These are not theological claims about human sinfulness or divine justice. They are engineering specifications for a managed system, and the management protocols described include periodic resets, whose physical signatures appear in the geological record with a regularity that modern paleoclimatology has documented independently of any ancient textual tradition. The Younger Dryas impact event 12,900 years ago, the 8.2 kiloyear cold event, the 4.2 kiloyear aridification event that collapsed the Akkadian Empire and the Egyptian Old Kingdom simultaneously. These are not mythological catastrophes, they are geological facts, and the ancient administrative records that describe both the management protocols and the transmission of survival knowledge across these events are not mythological responses to geological facts. They are historical documentation of a management system whose physical effects we can independently verify. What modern civilization is positioned to do with this understanding is a question that the ancient texts also address. The Apkallu transmission system, the sealed underground repositories, the bloodline preservation protocols, the astronomical return cycle calculations documented in the Neo-Babylonian administrative records, all reflect a long-term planning horizon that dwarfs any institutional framework that contemporary civilization has constructed. The beings who established these systems expected them to function across timescales measured in millennia, and the physical evidence suggests that they did. The knowledge that arrived in Sumer between 3,500 and 3,000 years before the Common Era, transmitted through the 6 technology domains examined in this investigation, enabled the development of every subsequent civilization that built upon the Mesopotamian foundation. That foundation was not human in its origin. The tablets say so clearly. The physical evidence confirms it systematically, and the 6 technologies that modern science cannot reproduce from the resources and capabilities conventionally attributed to ancient Mesopotamia remain in the archaeological record as the most direct available evidence that the Sumerian administrative records are precisely what they present themselves as being: documentation of contact with intelligences whose capabilities exceeded our own, whose purposes in establishing that contact remain imperfectly understood, and whose departure left behind both the physical evidence of their presence and the textual instructions for what to do when they return. The investigation now complete, what remains is not a collection of anomalies, but a coherent historical account that the evidence across every examined domain consistently supports. 6 technology categories appeared in Mesopotamia without developmental antecedents. The same 6 categories appeared simultaneously in Egypt and the Indus Valley. The civilization that produced all 3 appearances attributed them uniformly to the same source, documented that source in administrative rather than mythological language, and preserved the technical specifications in sealed underground repositories explicitly designed for recovery by future civilizations following catastrophic disruption. The physical evidence corroborates the textual claims at every point where modern instrumentation has been applied to examine it. The geophysical anomalies at Nippur and Uruk confirm the presence of materials whose composition the cuneiform texts describe. The genetic anomalies in ancient elite populations correspond to the biological procedures the texts document. The mathematical content of the astronomical corpus corresponds to methods the texts attribute to non-human transmission. The pattern is not ambiguous, it is comprehensive. What this pattern requires of contemporary scholarship is not credulity, but intellectual honesty about the limits of the frameworks currently applied to the ancient record. The developmental model that underlies conventional archaeology, the assumption that human technological and social complexity always increases gradually through accumulated innovation, is not a finding of the archaeological evidence. It is a premise imported into the interpretation of that evidence, and when the evidence consistently violates the premise, the scientifically appropriate response is to examine the premise rather than to explain away the violations. The Sumerian record violates the developmental premise at every level simultaneously. 6 technology domains, 3 civilizations, 1 narrow transitional window, and a body of textual documentation that attributes the entire pattern to a single source, whose characteristics the texts describe in operational detail. The premise cannot survive the evidence. What the evidence survives is the question. The cyclical pattern embedded in the ancient texts adds a dimension to this question that extends beyond historical inquiry into immediate practical relevance. The same administrative records that document the transmission of the 6 technologies also document the protocols established for civilizational collapse and knowledge preservation across it. The sealed repositories, the trained bloodline intermediaries, the astronomical return cycle calculations, the encoded technical knowledge distributed through mystery school traditions whose institutional descendants remain active in the present. These were not preparations made for a single anticipated catastrophe. They were infrastructure established for a recurring pattern of civilizational rise, technological achievement, and periodic reset whose geological signatures appear in the physical record at intervals consistent with the astronomical cycles the ancient texts specify. We are not the first civilization to reach the threshold of technological capability that the ancient records identify as the boundary between sustainable development and systemic collapse. We are the most recent. The distance between those two outcomes is not measured in technical capability. The ancient administrative records are unanimous on this point. It is measured in the wisdom applied to capability already possessed. The tablets have been waiting for 4,000 years to be read as what they are. The question they pose to the present moment is whether the civilization that finally reads them correctly will do so in time to matter.